Hello, ladies and gentlemen. Welcome back to math. Today, we're going to cover those identities we covered last class. Last class, I gave you the chart to look at to get a little more understanding of what we're going to be covering on the next few concepts. Okay. So the objective for today is to know how to convert equations using the trigonometric identities. Okay, or the trig identities. I will say this, guys. There are different ways to solve things, okay? As long as you get the right answer, okay? That's the most important part, okay? There's, like I said, a few different ways to solve for them. I will say this. Today we're gonna need that little chart I gave you last class, okay? That little chart on top, okay? All right, I'm not gonna redraw it on the board because it's gonna take a lot of space on it, okay? I will say this. The goal for today is to solve for a specific thing. Sometimes you have to convert it. Okay. For example, if I have, let's start with something very, very basic. If I were to say, I want to solve if, okay, if, let's start with, if sine theta equals 1/3, find secant, okay? That is our example for today, for our very first one. We'll say something a little more basic. By looking at the identities, okay, we know that sine is 1/3, okay, sine theta. So if we look at all the identities, we have quotient, reciprocal, and Pythagorean identities, okay, on that chart. We're gonna use, we can't really use the quotient one because it's tangent, okay, we have nothing to do with tangent here, okay, so we know we don't have to use those. Reciprocal, okay, I mean, we could convert sine, okay, I mean, we could, but there's an easier one, okay? There is on Pythagorean Theorem. There's one that says cosine theta, okay? Let's do another color here. Cosine squared theta plus sine squared theta equals 1. Okay? That's the theorem I'm going to use. Okay? The reason why is because we have sine in the equation. We know what sine is. We can rewrite it as cosine squared theta plus, instead of sine, okay, can we say 1/3 square, keep the square because sine theta is what we really need, square equals 1. Okay, so again, cosine square theta plus 1 times 1, because remember, square is for both. So think of it as we're saying square here and square here. Okay, think of it as that way. So 1 times 1 is 1. 3 times 3 is 9 equals 1. Now we can move the 1/9 over here by subtracting 1/9, right? Because it's the opposite. Because we're trying to leave cosine theta alone. Whatever you do to one side, you have to do to the other. Okay? So we have minus 1/9. So now we have cosine squared theta equals, okay, equals 1, which 1 can be converted into an actual fraction, okay? Always use the denominator you're dealing with. In this case, it's 9, it's the biggest denominator. So we can say 9/9 minus 1/9, okay? equals cosine squared theta equals 9 minus 1, since we have the same denominator, and we're subtracting. 9 minus 1 is 8 over 9. We keep the denominator. Keep in mind, guys, we're going to try to get rid of the square. The way we got rid of the square is we radical the equations to get rid of the square. We're left with cosine theta equals radical 8 over radical 9. Since 9 is a perfect square, we can actually say cosine theta equals radical of 8 over 3. Okay? Now that we have cosine, cosine is the opposite of secant. Okay? So technically, all we have to do to convert it to secant, which is what we're looking for, is we have to flip the numbers. So secant theta equals 3 over radical of 8. Okay? I will say, well, I don't want to go any further than this for now. Okay? But technically, you really can have a radical on the bottom. But for the purpose of today, okay, just leave it as it is. If you want to do that extra step and you know how to do it, go for it. I encourage you to do it. Okay? But since for the purpose, since we're looking for secant theta, which we did, we converted cosine theta into secant theta, which was 3 over radical of 8. Okay? This is why I told you guys we need to learn those identities. Okay, we need to get familiar with them. We need to know how to use them. All right. So now that we have this one, let's do one more. Okay, make sure you have it down on your notes. I'm going to step out of the screen here for a second. All right, I hope everybody has them or has this specific equation or problem already written down. You might get something very, very simple at times, okay, where it might say go from tangent to cotangent. If tangent is 2, what is cotangent? What we have to do is just right away flip it, and that's it, okay? But let's say we got, let's go with, if CSC theta, let me forget to put theta in there, theta equals 12 over 5, find cotangent. All right, so now, again, we're going from cosecant to cotangent, okay? Look at the chart, okay? Notice that we don't have anything, well, technically we do have something for this one, okay? So this one's pretty much something that we already have, but for the purpose, if let's say we didn't have something for cotangent with secant or cosecant, we can always convert cosecant into sine, okay, and then use another equation basing it off of that, okay? But we do have an equation that works specifically for this one, which is cotangent squared theta plus 1 equals cosecant squared theta. Which again, we already have cosecant, which is 12 over 5 squared equals 1, or cotangent squared theta plus 1. Okay, so that's 144. So cotangent squared theta plus 1 equals 144 over 25. We subtract 1 on both sides. Cancels out. We have cotangent squared theta equals 144 over 25 minus 25 over 25. The reason why is because we want to get the same denominator. Since it's a whole number, it's 25 over 25, which makes it a whole number. So 144 minus 25. We have, let's see here, let's do it the old-fashioned way. Borrow is 3, 14, that's 9, that's 1, 119. So we have cotangent squared theta equals 119 over 25. Again, we have a square, so radical. So cotangent theta equals radical of 119 over, again, 25 has a perfect square root, which is 5. So cotangent theta, it's pretty much already done for you. So it's radical of 119 over 5. Okay? Notice that some of them already come pretty much done once you get the first part. Some of them you have to do that extra step, go to another equation to actually solve it. In other words, you have to convert it. Okay? So keep an eye out for that. All right, so here's your assignment for today. Where's my, here we go. All right. The ones you have to convert are, number 1, if cotangent theta equals 4, find tangent theta. Okay. Number 2, let's go with if tangent theta equals 4 over 3, find cosine theta. And finally, for number 3, if cosine theta equals 5 over 7, okay, find cosine or sine theta. Alrighty, make sure you submit your answers as soon as you're done watching the video, and I'll be here waiting for your email.